You ever just stop and think about the ground beneath your feet? It feels solid, stable, right? But it's actually whipping around at an incredible speed. So what if it just stopped? It sounds like something out of a wild sci-fi movie, but when you look at the real physics behind it, wow. You start to see how much we rely on our planet's constant motion. All right, let's dive in and really unpack this.
So let's just ask the big question right up front. What would actually happen if, in one single instant, our planet just slammed on the brakes? The consequences, well, they'd be more extreme and way more immediate than you can possibly imagine.
Okay, first up, let's tackle the most dramatic scenario, the one you see in the movies, an instantaneous, catastrophic stop. We're not talking about a gentle slowdown here. This is like pulling the emergency brake on the entire planet.
The key thing to understand here is inertia. See, if the Earth's surface suddenly stopped, everything on it would not. The atmosphere, all the oceans, every building, you, me, we'd all keep rocketing forward at the planet's original speed. If you're near the equator, that means you'd be flung forward at over 1,600 kilometers per hour. That is literally faster than the speed of sound.
Astrophysicist Neil deGrasse Tyson puts it pretty bluntly. The momentum would be so insane that, yeah, people would literally just be flying out of windows. It would be a single, global, catastrophic event.
And the chaos wouldn't stop there. Not even close. The atmosphere, still moving at that incredible speed, would basically become a supersonic windstorm powerful enough to scour the very surface of the planet. The oceans would surge into mega tsunamis that would just swallow entire continents. And the sheer physical stress on the planet's crust from a dead stop, it would trigger massive earthquakes and volcanic eruptions everywhere, all at once.
So, why would this level of chaos happen? Well, it all comes down to some really fundamental forces. To really get a handle on the consequences, we first have to understand the physics that keeps our world spinning and, stable. Think about it like this. When you're in a car cruising down the highway, you don't really feel the speed, right? Because you're moving with the car. But what happens if the driver slams on the brakes? You fly forward. That's inertia. Now, just scale that up to the size of a planet. We are all passengers, and that would be one heck of a jolt. So, why has the Earth been spinning for over 4.5 billion years anyway? The answer is something called the conservation of angular momentum. It's the exact same reason an ice skater spins faster when they pull their arms in. Our planet got its spin from the giant cloud of dust and gas it formed from, and there's just no major force out there in space to stop it.
And all that spinning creates another really important force, centrifugal force. It's this outward push that actually causes our planet to bulge out a little bit at the equator. It's not a perfect sphere. Now, this force is holding back a massive amount of ocean water in that equatorial bulge. You're going to want to remember that because it's about to become very, very important. But what if the stop wasn't so sudden? Let's change gears. Imagine the Earth slowly, gradually decelerated over decades. The instant violent chaos would be gone, but the planet itself would be reshaped into something totally unrecognizable.
Okay, so without that spin, the centrifugal force just vanishes. Gravity takes over completely. That 8-kilometer high bulge of ocean water we just talked about, it would start the single greatest water migration in history, flowing away from the equator and toward the poles. What you'd end up with are two unbelievably huge polar oceans, and in the middle, as all that water drains away, a single continuous band of land would emerge, an equatorial supercontinent wrapping around the entire globe.
Now, could you even live on this new planet? The new map would be the least of your worries, believe me. A motionless Earth would have a totally different and frankly a much more hostile climate.
Just think about this for a second. A single day would last an entire year. One half of the planet would face the sun for 6 straight months, baking the land and boiling the oceans. Meanwhile, the other side would be plunged into a 6-month-long night of unimaginable cold, freezing absolutely everything solid.
And there's another invisible threat. Our planet's spin is what drives the molten core, and that motion generates the magnetic field that protects us all from deadly solar and cosmic radiation. Without the spin, that shield would weaken, or maybe even just disappear entirely, leaving the surface totally exposed. Life as we know it would be pretty much impossible.
So this has all been a pretty wild thought experiment, right? A fun little what if. Well, here's where things take a stunning turn and actually collide with reality. Because the truth is, the Earth is slowing down, and recent data shows that something totally unexpected is happening.
For billions of years, the gravitational pull from the moon has been acting like a very, very gentle brake on our planet. It's a natural process called tidal friction, and it's been gradually making our days a tiny bit longer over millennia. But since the year 2000, scientists have noticed that the rate of this slowdown has started to speed up.
That's right. This isn't just a theory. NASA has confirmed it. The change is real. So the big question is, what's causing it? The moon's pull hasn't changed, so something else must be going on.
So let's put a number on it. Since 2000, the rate that our days are getting longer has jumped to about 1.33 milliseconds per century. Now, I know that sounds incredibly tiny, right? But that's not the point. The significance isn't the amount, it's the change in the rate of change. It's happening faster now than at any other point in the last 100 years.
And the cause? Well, it turns out it's directly linked to climate change. Remember our ice skater analogy? As the massive ice sheets in Greenland and Antarctica melt at an accelerated rate, all of that water mass moves from the poles out towards the equator. It's the planetary equivalent of that skater extending their arms out, and it's causing our entire world's spin to slow down. And this quote from NASA scientist Surender Adhikari it really says it all. This shows we aren't just changing the weather on the surface. Our actions are now measurably altering the fundamental mechanics, the very rotation of the planet itself.
And that kind of leaves us with a final, pretty sobering question. If our actions can have consequences on this massive a scale, affecting something as fundamental as the length of a day, what other huge, unseen changes might we be setting in motion right now, without even realizing it?